Hi, everybody. Welcome to Monday. I'm Angie, and I'm an interpreter for California State Parks. And today, our 3 o'clock live stream is going to be really awesome. So thanks, everybody, for tuning in. For those of you that know, we do these every day. We thank you for being here consistently and for joining us. If you're new, welcome. So today, we are going to be talking about a really awesome topic called spume. Now, I'm curious if anybody out there knows what spume is. If you do, go ahead and type it in the chat. I'll give you a hint. I'm actually going to walk you over to close to the surf zone so we can check out some spume and see if any of you are right about your knowledge of spume. So here we go. I am out on the peninsula today, what we locals call it here on the North Coast. Basically the peninsula between the city of Arcata and the city of Eureka, right off the coast of the town of Manila. So that's where I am today. And you can notice there's a lot of white water in our ocean. This is our pretty regular, consistent scene at this beach. We've got a lot of motion in the ocean, lots of waves, and we also have some spume on the ground. So if you guessed that spume was sea foam, what a lot of people usually call it, then you're right. And today we don't have a whole lot of sea foam washing up on our beaches, but you can definitely see some. Basically, as the waves come in, they leave a little bit of sea foam behind. I'm going to run away so I don't get wet. So today we're going to talk about sea foam and about what we call spume. Some people call it ocean foam, has many different names. Let me get you resituated on here. And the other night, I was out here at the same beach for sunset, and I saw some spume, so I took a photo for you all. Maybe you can see that. Here we have a big old pile of sea foam. Now, have you ever walked on the beach and wondered, what is all of that soapy foam doing on the beach? In some cases, the spume can be really noticeable. It can cover beaches in some cases. There have been massive events of sea foam in some places in the world. And sometimes we don't have a whole lot of spume or sea foam on our beaches like today. So we're going to talk about what it is, how it forms, and what we can do to make sure that spume doesn't mean doom for our marine environment. All right, let's see. Hi, everybody. Yeah, Robin and Braid said sea foam, question mark? Yeah, so you probably knew what spume was already. All right, my friends, so we're going to do a little experiment today. I'm excited about this. Kind of related to chemistry and oceanography. So I have here just a jar of plain water, just from the tap, fresh water. And I'm going to go ahead and shake this up, right, to simulate the ocean waves here. Like I said, lots of motion in the ocean up here on the North Coast. And do you think that lots of bubbles are going to form in this water, this fresh water straight from the tap? I'm sure most of you are thinking, no, I've maybe shook up some water before. And you might see at the very end, we have some bubbles at the surface, but they're very small and they're not very persistent. So they pop really, really easily. So I'll do that one more time so you can see. I'm shaking it up, shaking it up, shaking it up. This is just our fresh water straight from the faucet. And we don't see many bubbles here. And that is because of something called surface tension. So today we're going to talk about surface tension and what it has to do with spume. So essentially, surface tension is the force that keeps water molecules together. They are all attracted to each other. They want to hang out with their neighbors, and they basically pull each other in close. They're not very good at physical distancing. They like to be close together. So essentially, at the surface of our water, water molecules are pretty close together because they are much more attracted to the water below them than they are to the air molecules above them. And this is that force of surface tension. So essentially the molecules here are really close together and they form a force called surface tension. Now, surface tension is really, really cool because it is what allows water skeeters to walk on water. If you go to any of the creeks in Humboldt Redwoods, or not Humboldt Redwoods, in all of North Coast Redwoods District, and I was in Humboldt Redwoods the other day and I saw lots of water skeeters there. So if you go to any of our creeks, you'll see surface tension in action. So the water skeeters have an adaptation that allows them to take advantage of surface tension, and their superpower is walking on water, which is super cool. So go check that out. And next time you see a water skeeter, say, hey, you're taking advantage of surface tension. So I'm going to show you, I'm going to do a little experiment here. So I'm going to point the camera down, and I'm actually going to show you some surface tension in action. You might be thinking, wow, Angie, you are a magician, and I'm practicing. So I'm actually going to make a paper clip float on this jar of water here. Remember, just fresh water from the tap, and it's going to exhibit surface tension for us. So let's begin. All right, so we have our jar right here of fresh water, and we have a red paper clip. Let's see, there we go. And I'm going to float this paper clip on the surface of the water for you all using surface tension. Prepare to be amazed. Ta-da! Now, of course, we know that the paper clip is heavier than the water, so it should sink. But right now, because it's pretty flat, has a lot of surface area, it's floating on the surface of the water using surface tension. So now I want to introduce a concept of surfactants, and that's really what creates bubbles and what creates our sea foam or our spume. So surfactant is basically a substance that reduces the surface tension of a liquid. Okay, so when we add a surfactant into the water, we will see that surface tension be reduced, and maybe you can make a guess of what's going to happen as the surface tension that's holding up the paperclip is going to have, what effect it's going to have on our paperclip. So I'm going to point you down again. All right, our paperclip is still floating. How amazing. And in this container right here, let's see, I have some soap, so some detergent, just like some dish soap from my house. So I'm going to go ahead and take this little stick, poke it in the detergent, and then I'm going to go ahead and drop some soap onto the surface of the water, and just like that, our paperclip sinks to the bottom because the surface tension in our jar of our liquid was reduced, and therefore the paperclip could no longer rely on that tension to keep it on the surface. So neat. All right, my friends, so that's a little bit about surface tension. Like I said, it's what holds water molecules together. And of course, you know that bubbles are basically just a layer of water kind of sandwiched between two places full of air. So the inside of the bubble and the atmosphere. So how can you create bubbles when all those water molecules just want to be close together all the time? And the key is to have a surfactant. So now you know a little bit about bubbles, a little bit about surface tension, and you can probably make an educated guess that all of those bubbles have something to do with surfactants when we talk about spume and about sea foam in the ocean. All right, my friends, I'm going to pull out a diagram that I made of a bubble for you all. Hang tight. Okie doke. So here we have a very simplified image that I drew of a bubble, okay? So you can see over here, our little key says water. So this blue line is a thin layer of water that forms our bubble. And then on the outside, we have this green and red shapes. These all represent our surfactants. So essentially on one end, they have a hydrophilic end, which basically means that they're attracted to water. And on the other end, they have a hydrophobic end. So if you're phobic of something, you don't like it, right? You don't want to be near it. And the hydrophobic end faces away from the water. Now, a bubble is formed basically by creating a double-sided wall of surfactants around a thin layer of water, and this is what creates a bubble, and especially a bubble that doesn't pop very easily like the ones we saw before, okay? So some examples of surfactants that are human-made would be detergents, soaps, fertilizers, and even human waste like sewage. But there's also natural forms of surfactants, and many of which exist in the ocean. So we're going to talk a little bit about that now. So some examples of surfactants that exist in the ocean are basically dissolved organic matter that comes from algae or dead animals or dead plants that live in the ocean and break down into basically simple pieces of proteins and lipids or fats. So we have lots of naturally occurring proteins and fats that are living out in the ocean and that eventually break down into what we call dissolved organic matter, and those are also examples of surfactants. All right, so now I have another fun demo for you all. Here, in this jar, I have an egg white. Now, an egg white contains a little bit of fat and quite a bit of protein. So remember, we said that there are naturally occurring fats and proteins that act as surfactants. Of course, this is a chicken egg, didn't come from the ocean, but there are a lot of examples of things in the ocean like fish and like algae that do have proteins and fats. So we're going to use this as our example, all right? And I'm going to go ahead and add some fresh water into our egg white and shake it up and see if we get some bubbles. What do you think? Maybe you've made meringues before with egg whites, so you have an idea of what happens when you agitate an egg white. We're going to add some water, my reusable water bottle. Okay, add some more. I'm going to screw the lid on really tight. Remember, our egg white is representing all the fats and proteins that exist naturally out in the ocean from fish and algae, and I'm going to shake this thing up. You might already be able to see what is happening, but we have lots and lots of bubbles. I'll go ahead and open it up so you can see. Tons of persistent bubbles, way more bubbles than we saw in our plain water. Now this has a little tiny bit of soap in it, so it looks a little different. Lots and lots of bubbles. So of course we know that the ocean is moving all the time. The surf zone specifically is the area that is most commonly known for having white water or for having spume or sea foam. So that's why we have sea foam on our beaches. Pretty interesting. Now I want to get back to the idea of, does spume mean doom? And in some cases, spume is caused by those natural things that exist in the ocean, or it can be caused by human things, like maybe a discharge of fertilizers or even sewage. And other things that could happen naturally would be like an algae bloom. So if we have a big algae bloom and a lot of maybe plants and animals in the ocean that are dying off, letting out those proteins and fats into the water, we might see a lot more spume here on our beaches. Now, it is possible to have harmful algae blooms and also possible to have good algae blooms, okay? So if we have an algae bloom either in a local river or right off the coast here, in some cases that can mean a massive decrease in oxygen in the water, which is not so good for animals that, like fish, that need oxygen in the water. A lot of algae can also block light, and sometimes it can actually block the gills of fish or other animals, so that's not so good. And essentially, an algae bloom, no matter what type it is a good indicator of environmental change. And that environmental change can be happening out in the ocean, whether it's an algae bloom or environmental change happening on land. Maybe we have a land-based pollutant that's making its way into the ocean. So spume isn't always a bad thing. It definitely is naturally occurring. And if you do see a lot of spume, maybe it's a good indicator for you to research maybe what's going on. Is there an algae bloom happening? Is it a harmful algae bloom? That would be important to know. And or is there maybe some pollution making its way into the ocean that you weren't aware of? And maybe you can advocate to stop it, right? So spume doesn't always mean doom, but it can be a good indicator of what's going on either on land or in the ocean. One thing we can all do to make sure that fertilizers and human-made surfactants don't make their way into the ocean is by reducing the amount of fertilizers that we need to live. So if you eat organic, now is a great time to pat yourself on the back. Less fertilizers, less pesticides making their way into our watersheds. All watersheds lead to the ocean. So if you're not using food that uses a lot of pesticides or uses a lot of fertilizer, or maybe if you're a gardener and you like to make an organic garden, you are helping to reduce the amount of surfactants, human-caused surfactants, that end up in the ocean and could be harmful. In some cases, an algae bloom, or I guess I'll call it a spume bloom, can, in the past, in other places in the world, seabirds have actually been massively affected by an overgrowth of spume because the surfactants, those detergent-like compounds in that soapy substance, actually de-waterproofed the feathers of the birds, so they basically died of hypothermia. So in some cases, a lot of spume can be harmful. So I hope that was helpful and exciting. I know I've walked on the beach many times and wondered, what is sea foam? Where does it come from? How does it form? So now you learned a little bit about surfactants, about surface tension. You can go check out some water skeeters in our local creeks. And you can be a little bit more aware of the environmental changes that are happening around your local coastline or a coastline that you love dearly. So thanks everybody for tuning in. I'm so grateful that you're all here. We are taking lots of COVID precautions to help keep ourselves and our community safe. And we do these live streams every day at 3 o'clock. So we hope you'll continue to tune in and engage. If you enjoyed this video, go ahead and like it and share it. And we'll see you again tomorrow at 3 o'clock. If you have any questions, go ahead and type them in and I will answer them in the comments. Bye.